Okay, so very first thing is, with these, when we're solving, just like we did in equations, going to add 15 to both sides. So 8x less than 88, just like we did yesterday, you're going to go back and then divide both sides by the number with the x. You got x less than 11. Okay, when you graph these, on the number lines, I would say just put the number we've got to graph in the middle and put one or two numbers on either side of it just to make sure you got a few numbers in there. And same thing we said yesterday. This one you got to open circle at 11. And as long as the x is first, the arrow is going to tell you which way to go. So in this case, that arrow is pointing to the left, so you've got to go to the left. So those two arrows have to match up. And that's just going to be everything in between those two. And then the last thing with interval notation is, once you've got the graph, just tell me, all right, on the graph, we're definitely stopping. 11 is definitely the right-hand number, so that's got to go here. To the left, we're chasing this thing all the way down, so that's negative infinity. And again, infinity or positive infinity, you always use parentheses. The 11 is an open circle, so for that one, we're going to need parentheses there for that part. Yes. Okay, example 2. Negative 3 times 2x minus 5 plus 1 less than or equal to 4. And this has got one thing at the end of it that I picked this problem in particular to show you some, this one, because there's one specific thing on this one I want to make sure that you see on the inequality, because it's got the one thing on it that's different, and we got to make sure to remind you of what that part is when we go through this. Yes.
So when we give you the answer, let's say this is a test or whatever, if we don't have.
Okay, for this one, first thing is you're going to multiply by negative 3. Makes that negative 6x, and again, it is negative 3 times negative 5, so that's a positive 15. Now, here's where you've got a couple options, but you've got the 15 plus 1 that's together on the left-hand side of the equal sign, or the less than sign. So for those two, you can go ahead and put those two together and just make that a plus 16. Now, you can move them one at a time if you want to, but since they're on the same side, just go ahead and just put the signs together, because you got 15 plus 1, just go ahead and make it 16. Okay, once you put those together to make it 16, then you can go ahead and get rid of those numbers at one time. And that way you're only having to subtract one time and not having to subtract 2 times, which usually for most people makes it a little bit better. So now you've got negative 6x less than or equal to negative 12. All right, divide by negative 6. We've got the x. That'll make that a positive 2. And here's the one time where you have to be careful. Your answer is going to be x greater than or equal to 2. And here's where we'll put a little side note on the side. Hopefully this will come back to you when we mention what it is here. That if you multiply or divide both sides by negative, there you go. You must flip the sign. Okay, and that's the only thing that's really different about equations and inequalities. If equal signs, you don't have to worry about flipping the sign. But if it's inequalities, now it's only if you do it on both sides, because sometimes people go, well, why didn't we do it back up here with the -3? Because we multiplied by -3. Well, we only did that -3 on the left-hand side. We didn't do it on the right-hand side. So it's only when you do the negative, multiplying or dividing on both sides. If you do it on both sides, you've got to flip that inequality around. All right, and we'll just do a quick sketch on the graph here, because again, that graph's pretty straightforward. And there's 1, 2, 3. And if you're wondering if you'll have one like that on the test, absolutely. I'll tell you right now, you're going to have one of those in there where you're going to have to flip your inequality sign around. So I can guarantee you that'll be on the test. So for this one, solid circle at 2. Now your arrow is going this way, so we got to go in that direction. Alright, if we want to do interval notation real quick, again, leftmost number, that's at 2. Again, it's going to the right, so it's always going to be infinity. So if you had to write that answer in interval notation, that would be 2 to infinity. Okay, now, in the other part of section 5, it fits in here, but they also throw a few other little things at you. I think it was section 4. This is where they're going to ask you to write an inequality and solve, which means it's going to be a little bit of word problems. And some of these you may not actually have to do any solving. It may just be more some of these you're just going to write an inequality. So it's more one of those things that they go back and kind of review. So let me just show you the basic things first that you need for this one, and then they'll throw a couple other things at you. Again, we're not going to make these real long equations or inequalities when we're going through. That'll be pretty short. All right, this one says the number is at least 15. Now, here's the thing. And this is where you got to be a little bit careful with these, because a lot of times, and we've told y'all in the past, and I'm kind of guilty of this too, that if you're doing a word problem, you go back through and look for the keywords on it. Well, the keyword on this one is least, right? But it's at least 15. It's kind of like getting your driver's license, right? You have to be at least 15 if you're gonna drive with a permit, which means, if you've got a number, that's your X part. If it says at least, well, that actually means that's greater than or equal to 15. And for that one, you don't have to solve it because you're just writing the inequality. It's pretty much already solved there. So that's the one thing you got to be a little bit careful of, is that they tell you that that's at least, that really means that's greater than or equal to. So in the past, where we've told you, if you get a word problem, go back and look at keywords. This case, this is kind of the opposite. This one, no, you have to take your time and read the whole thing out to make sure you understand what it's saying. Because you haven't said least, but if it's at least 15, that means that's the lowest number you can have. Everything's got to be bigger than that 15 or greater than the 15. Okay, and then on the flip side, if they tell you that a number is at most, I don't know, 30. Well, if it says at most, that's just the opposite. That means it's less than or equal to. If you're putting variables in, it doesn't matter if you do X or T or N. Just put some letter. It doesn't matter what letter you use there. If it's at most 30, that means that's as big as it can be. So it's going to be T less than or equal to 30. Okay. Now that's not a big thing, but sometimes, again, if you're going through, if you're going through some of these, if you just start looking for keywords, sometimes people look for least or greatest. They'll kind of key on that one, but this one says if it's at least 15, that means that's the lowest number you can be. All right, let's give you one that's a little bit more of a word problem here. Let's do 4 subtracted from a number is greater than 21. Let me do that again. All right, so 4 subtracted from a number. You got to do subtraction. It's greater than 21. Here you got to be a little bit careful. It's not just 4 minus a number, because it says 4. You're taking 4 away from a number. So it's some number, and then you're going to take away 4. So it's x minus 4 greater than 21. So in that case, just add the 4 to both sides, and then you got your 25. And subtraction is one you got to be a little bit careful. Sometimes when you're doing subtraction, it's a reverse order. So remember, if you're subtracting it from a number, you have to start with that number and then take that 4 away from it. Addition is not that picky, because if you add 4 in front or back, it's fine, but subtraction is kind of specific about where you want it. The only other things you need to remember, product. Just remember that means you got to multiply. And quotient means you're going to have to divide. Other than that, everything else is pretty straightforward. It'll tell you it's 3 times the number. You got to multiply by 3. So you'll see some mixture of word problems through section 5. There may be 1 or 2 snuck in with section 4. But for the most part, if you just remember that product means multiply, quotient means divide, and just be a little bit careful with your subtraction problems. That's about the only thing you've got to look out for. All right, now here's where we're going to go back to the stuff we were doing yesterday, I think it was. We're going to go back to the always, sometimes, or never true. But the only thing on this one is that we're not just doing equations. This time we're going to do inequalities. But if what we did the other day made a little bit of sense, what we're going to do today basically is the same thing, but now we're just using less than and greater than. Okay, just like for the other one, if it tells you if it's sometimes, always, never true. We solved the equations. This one, you're still going to solve the inequality. You still have to put the work in. You don't just guess and go for that part. Because, test-wise, I may tell you, tell me the answer, but at the same time, show me your work. Show me how you got there, other than just, don't just take a guess. All right, so after you solve that, then you got one of 3 things, and it's kind of the same thing. If you have a variable left over, then it's going to be sometimes. Just like when we did the equations, if you were to have x equals something, it was always going to be sometimes. Same thing with this one. If you've got x is greater than something, or you've got x is less than something, if there's a variable in your answer, it's going to be sometimes. Doesn't matter if it's x less than 4 or y or greater than or equal to negative 13. Doesn't matter. If you've got a variable left in your answer, it's going to be sometimes, every single time. Okay. And just like we had the other day, if you don't have a variable, that means you've got two numbers left. Now, the other day we had the same two numbers or different two numbers. This one's going to change because we're not necessarily worried about which numbers they are. We're more worried about how they compare. So if you don't have a variable and the numbers that are left make a true statement, it is always true. Or just, for the most part, we're just putting always. Is 0 less than 8? Yeah. All the time, right? Well, unless you're getting shots, Would you have 8 shots or 0 shots? Well, that's a little different. But, we're talking about just numbers. 0 is less than 8. We're okay there. Is 10 greater than -2? Yeah, that's true, right? So, in that case, if you've got two numbers at the end, you look at it and you go, well, yeah, that makes sense. So then it's always true. Now, just be a little bit careful with your negatives. Sometimes if it's been a little while. If it's -10 and -12, remember that -10 would be greater than -12. Okay, and then your last option is if you don't have variables, and the numbers make a false statement. And it's going to be never true. So we can take numbers that we had up here and flip it around and say is 0 greater than 8? Well, no, because 0 is less than 8. Well, if that's not true, doesn't matter what numbers you plug in, it will never be true for that thing. Is 4 less than or equal to 3? Well, 4 is not less than, it's not equal, so no, that's not true. Is -10 less than -20? No, because -10 would be greater than 20. Oh, now here's a good one. Here's kind of, let me give you this one. Kind of think about it, because sometimes this one will throw people off. Every now and again, you will get the same number and itself with the less than or greater than. So let's say you get something like this, where you got 7 is less than or equal to 7. Now, before you say anything, just think in your head. You don't have to say any answer out loud. Just kind of think about it. In your mind, just think, well, is that true or is that false? Because sometimes people get a little thrown off on this one, because it goes 50-50. Some people say, well, 7 is not less than 7, which is true, because 7 is equal to 7, right? And if you read this off, it says 7 is less than or equal to 7. So it's not less than, but it is equal to. So in that case, that one would be a true statement. If you took just that less than off, or sorry, if you took the equal to off, if you said 7 less than 7, that would be a false statement. So if it fits in either one of if it's the same two numbers, if you've got that bar underneath it with the equal to part, then it's true. If you don't have that bar underneath it, then it's going to have to be false. And sometimes that throws people off because they're like, well, but it's not less than. No, it's not less than, but it is equal to. Because that or statement says it's less than or it's equal to. All right, so there's your always, sometimes, and never statements. for inequalities. We're not going to solve equations because we still got some solving equation stuff we're going to do on the last little bit. So we just don't get overkilled on everything here. We've got one more thing we've got to look at with a couple examples of each one of those, and then we'll wrap that up. But again, that's just one more thing of doing the always, sometimes, or never true. So you're still going to solve the inequality. If you have a variable in your answer, it's going to be sometimes. If you don't have a variable, then you got to figure out, well, is it true or false? And it's either always true or it's never true. All right, and then the last thing in section 5 we have to look at. We're going to solve and graph compound inequalities. And compound just means that you've got more than one statement, and there's basically two types here. One is an and, it's going to have the word and in it. The second one is going to have the word or in it. And when they put the word and in there, that means it's the overlap. It means it's got to be in both parts of the graphs. If it's an or statement, that's basically anything, either one of the groups. Sometimes they call that a union when you go through that one. And if it's the union, that means it's anything in either one. The OR graph is actually a little bit easier because you put whatever the answer is, you put all that on one graph and you've got everything you need. The overlap is the one you have to kind of put a little bit more thought process into it. Alright, so first thing we'll do, we'll do an OR graph first. And then we'll do an AND graph at the end. So, and again, it'll say and or in the statements when you're going through these, so there's not a whole lot of guessing about what it's going to say. And with the compound part, just means there's two parts to it. So all we're going to do is you're going to solve this part of the inequality, get that answer, you're going to solve this inequality, and you're going to have two separate answers, and we just got to put those two answers together to get one final answer off this thing. Alright, so first thing is you do have distributive property. So 4x plus 12 less than 16. You can get rid of the 12. And then you'll divide by 1. Sorry, divide by 4 so that you get x less than 1. Okay, so you don't do anything weird with these. You just solve the first inequality that they give you, then you solve the second one. On the second one, you are going to divide by negative 12. So when you do that, you do get x, you do get 12, but because you divided by negative, make sure you flip that inequality sign around. So it's actually going to be x greater than or equal to 12. Alright, and the graph on this one. And again, the or statements, the graphs are going to be really easier than the and statements, because all you're going to do is you're going to take these two graphs you have with these two numbers and just put them on the graph. So here's x less than 1. So you're going to do an open circle at 1. This one's got to go this way. This one you're going to have a solid circle at 12. And then it's going to go that way. And that's your answer. That's all you got to do. And of the two, the and the or statements we're going to do. The or statement is really straightforward. You just, here's the graphs. You put them on one graph. Anything it covers, that's your answer. And here's what we're going to do. One other little thing here. I didn't put it in the title. We'll go ahead and do it here. Also, go ahead and show you interval notation. Now, again, you're not going to, again, I want to take a second. You're not going to have to do this on the test, but it's good because later on we're going to have to do this. So if I go ahead and show it to you now, it'll be in good shape when we get to it a little bit later. All right, and this is one where you can kind of do it in two parts. Left side of the graph, it points to the left, so that's going to be negative infinity. Going up to 1, it's an open circle, so we'll put a parentheses there. The right side of the graph, we start at 12, and it goes to positive infinity. Square bracket on the 12, and then the infinity, got the parentheses there. Okay, now somebody's probably thinking, what about that gap in the middle? What do we do? You don't do anything. If you don't cover it on the graph, you don't put anything. The only thing you do here is you'll put a little U to say, all right, it's everything in this graph union with everything in this graph, or combined with. Now again, you're not going to have to worry about doing the interval notation on the test. I just want to show you that because we'll be getting to the interval notation soon enough, and y'all haven't seen it before, so we're just going to show it to you to actually get to the point where you have to get scored on it on the test. All right, let me show you an and graph. After we show you that one, I am going to show you a couple of trick questions, but we're going to keep them really short because some of these will pop up on some of the homework and on the test, so at least we'll let you kind of see what happens if you do get a trick question on some of these. Alright, so let's go with 2x plus 4 greater than negative 12, and then 9x less than 18. Okay, so working on the left-hand side of the graph. You got 2x plus 4, just need to subtract 4 from both sides. X greater than negative 16. Divide by 2. You got x is greater than negative 8. And again, for this one, you don't have to flip the inequality because when you divide it by 2, it was a positive 2. It doesn't matter that this one's negative. It really comes down to what is the x. If the x is positive, you don't have to flip it. If the number with the x is negative, that's when you got to go back and flip those signs. So it doesn't matter that the 16 was negative. You're more worried about this 2, whether it's positive or negative. And for the graph on the right, well, it's pretty straightforward. You just have to divide both sides by 9. So it's x less than 2. All right, now, here's where you've got to do a little bit different on the graph. I'm going to put a negative 8 and put our 2 here. Alright, has everybody seen the Lego movie? The Lego movie from a few years ago? You didn't see the Lego movie? Okay, we're gonna steal a little line from the Lego movie. You know how they made the double-decker couch in the Lego movie? This one you get to make a double-decker graph, because you're going to put a graph on the top and a graph on the bottom. Now, it's not going to save your life, because you're going to get blasted by the bad guy, bad cop there. But you're going to basically do this. You're going to put one graph on top, one graph on bottom, and then with the and part of it, you're looking for the overlap. And you may be thinking, well, how's that Lego? We just try to, bring some stuff in here. Try to make some things kind of funny if we can. So. All right, so for the x less than, this one's greater than -8. Start at -8, going that way. All right, for the x less than 2, we're starting at 2 and we're going that way. And for the overlap part of it, with the and part, that means you've got to tell me where those two lines would basically be on top of each other, where the graph is covering the same numbers at exactly the same time. Once you get to the left of -8, you've only got the green, so that part's out. Once you get to the right of 2, there's no green, there's only purple, so that part's out. So where you got your two colors, well, that's everything from -8 to 2. So your final answer on your graph, and it's almost one of those things where you have to kind of do a practice graph before you get to the final graph. That would be everything from -8 to 2 with a circle there and a circle there and then everything filled in the middle. So this is almost like where you have to kind of show your work. But you got to make a double-decker graph before you can kind of put it together and make out what you need there. Okay, if they ask for interval notation, which again, we're not going to do it on the test, but it is coming up really soon so we can practice on it. Once you've shown your work, you don't need that graph anymore. The leftmost number here is -8. The rightmost number is 2. There you go. And that one's a little different because we didn't use infinity, but interval notation sometimes, just depending on the numbers, you may not necessarily always use infinity because of, you're going to cut it off at 8 and you will cut it off at 2. We didn't go any farther than that, so that's the only two numbers we need there. Okay, and that's how most of the graphs should do. When you talk about an and statement, it's usually sandwiched between two numbers. If you remember and and the sandwich, because it kind of goes together, because there's an and in sandwich. And is usually sandwiched between two numbers. That's not two hashtags, that's two numbers. Social media now, you can't call that. Everybody used to know that was a number symbol. Now everybody thinks it's the hashtag symbol. It's like, no, that's the number symbol. We're not hashtagging anything here. So, and usually when you do an and statement, it's always sandwiched between two numbers. We'll show you one in a minute where it actually is not. It's a trick question. But and, it's almost always, most of the time, it's sandwiched between two numbers when you get finished with the graph on it. Okay, so here's where I'm going to show you a couple of trick questions where sometimes you get the answer and you look at it and you go, wait a minute, what kind of answer is that? And these, we're going to make the graphs really short. We're not going to do anything real complicated on these. So these will be really, really quick because we're not going to solve the equation. Just going to give it to you so you can see it here. And yes, one of these very well could pop up on the test. Definitely might get one of these on the homework. So, make sure you got these here. All right, we've got x greater than or equal to 1, or we've got x is less than 6. Okay, now with the or statement, again, a little bit easier because it's just one graph. You don't have to worry about it. No double deckers needed for the one part, for the or graph. We need everything that's greater than or equal to 1, so we need a solid circle at 1. This one's going this way. I'm just making that a little bit bigger so everybody can see for sure what the graph is there. This one is x less than 6. You're doing an open circle here, and now you're going that way. So what do we cover? Whole graph's covered, right? So if everything is covered, then that basically means this thing is always true. So that's basically what an always graph would look like. You're covering every single thing on that graph, because no matter what you do, give me a number, that number is going to have to either be greater than 1 or it's going to have to be less than 6. You know, give me 15. Well, 15 is greater than 1. All right, so we're good. Negative 2. Negative 2 is not greater than 1, but it is less than 6, so it fits. So no matter what number you pick, it'll always fit into one of those two categories. So it doesn't matter what you do, you can cover every single thing on that graph there. And if you have to do interval notation on this one, you're going all the way to negative infinity. You're going all the way to positive infinity. So that interval notation would be from negative infinity to positive infinity, because you covered everything that's out there. Okay, and then the one last one. We'll make this one an and statement. So we got x is less than 3, and we're going to do x greater than 4. Again, with the and statement, that basically means you got to go double decker. Now everybody's thinking about the Lego movie, for those of you who've seen it. You know, Lego movie 2 is coming out, right? Should be coming out in, I think, next little bit. Alright, so we'll put negative 3 on the top, so that's going that way. X greater than 4 is down here, going that way. Did the green and the purple ever wind up going over top of each other? They don't, do they? There's no overlap. So if there's no overlap, that's never true. And since you don't cover anything for that one, there's no numbers you ever actually touch. Interval notation, that's where they're just going to put a 0 and put a slash through it, because they're saying, all right, there's nothing that'll fit in this thing at all when you're going through these parts of it.